Secret leakage from context windows. This is one of the most frequently reported security incidents involving AI coding agents. Live credentials ending up committed to version control or transmitted to AI provider servers. Two separate mechanisms cause this, and both share the same root cause: how AI agents load files into their context window. Modern AI coding agents like Claude Code, Cursor, and Codex don't just see the file you're currently editing. They automatically load surrounding files to generate more relevant code. This typically includes the file you're working on, files in the same directory, project configuration files like package.json, environment files like .env and .env.local, and editor configuration files like cursor rules and MCP configs. This automatic loading is a useful feature. It makes the AI's suggestions more contextually relevant. But the problem is that .env files contain your live credentials, and the AI loads them without any warning. Here's how credentials travel from your .env file into your source code. First, the .env file, containing something like dbpassword equals your actual database password, gets automatically loaded into the AI agent's context window. Then, when the AI generates a database connection function, it has already seen the actual credential values. Instead of writing os.environdbpassword, a reference to the variable, it writes the literal password directly into the generated code. The developer reviews the code, sees that it works, commits it, and the credential is now permanently in version control history. The scale of this problem is well documented. According to GitGuardian's State of Secrets Sprawl 2026 report, AI-assisted commits leak credentials at roughly twice the GitHub-wide baseline rate. Claude Code specifically showed a 3.2% secret leak rate versus a 1.5% baseline across all public commits. In 2025, AI service secrets detected on public GitHub reached 1.27 million, an 81% year-over-year increase, driven largely by AI coding tools embedding API keys into committed code. GitGuardian also found over 24,000 unique secrets in publicly accessible MCP configuration files, of which over 2,100 were confirmed live credentials. The most common secrets found in AI-assisted commits include database passwords from NV files loaded into the agent context, API keys for services like Stripe, OpenAI, AWS, Twilio, and SendGrid, connection strings that bundle hostname, username, and password together in a single string, MCP configuration credentials, service tokens used by AI agent tool integrations, and OAuth client secrets from provider setup documentation that gets pasted into prompts. When a credential is committed to a Git repository, deleting the file or replacing the value in a later commit does not remove it. The credential is preserved in Git history and can be retrieved by anyone with repository access using simple commands like git show with the old commit hash. For public repositories, this is catastrophic. Automated secret scanning bots, programs that continuously crawl GitHub looking for exposed credentials, can capture a leaked secret within minutes of a push. Even if the repository is made private afterward, the credential has very likely already been captured. MCP, or Model Context Protocol, lets AI agents connect to external tools and services such as GitHub, databases, or Slack. When developers configure their AI tools to use MCP servers, the configuration file contains authentication tokens for those external services. These config files are frequently created inside project directories. If they're not excluded from version control, they get committed alongside the project code, exposing tokens for every connected service. GitGuardian found over 24,000 unique secrets in publicly accessible MCP config files, with over 2,100 confirmed to be live credentials sitting exposed in public repositories. There's a second, less obvious leakage path. The contents of the AI agent's entire context window, including your .env file contents, are sent to the AI provider servers as part of every API request, and those servers may retain that data for days. So we have two paths. Path 1, credentials end up in generated code which gets committed to Git. Path 2, credentials are transmitted to provider servers and retained in their logs for 7 to 30 days by default. Both paths originate from the same source, the .env file being automatically loaded into the context window. Most developers don't realize that AI provider APIs retain prompts by default. OpenAI retains data for 30 days for abuse monitoring. Anthropic retains for 7 days, reduced from 30 days in September 2025. GitHub Copilot has short-term telemetry-controlled retention. And Cursor sends data to the underlying provider with an optional privacy mode that must be explicitly enabled. Zero data retention, where the provider processes requests entirely in memory, requires an enterprise contract and is not enabled by default. Under default settings, a secret that enters an AI prompt could remain in provider logs for up to 7 to 30 days. This risk goes beyond automatic.env loading. Developers sometimes paste credentials directly into prompts. For example, sharing a database connection string and asking the AI to write a connection pool for it. A prompt is not a private channel. It's an API request payload that passes through the provider's infrastructure, may be logged, and is subject to the provider's data retention policy. The rule is simple. Treat every prompt as if it could appear in a log file, because under default settings, it will. Let's look at the vulnerable versus secure pattern side by side. In the vulnerable version, the AI had the .env file loaded in context. It wrote the literal password value directly into the source code, hard-coding the actual secret as a string, which then ends up in Git history forever. In the secure version, the code uses os.environ to reference environment variable names like dbhost, dbuser, and dbpassword. The actual values stay in the .env file locally and in your deployment secrets manager. They never appear in source files. This is the correct pattern. Code references variable names, and values are injected at runtime. The impact of secret leakage is severe. Credentials in Git history are permanent, accessible to anyone with repository access, including all future contributors. Public repository exposure is discovered by automated bots within minutes. A single leaked database password exposes every record in that database. Leaked API keys can be used to run up charges in denial of wallet attacks, access user data in third-party services, or send messages from your accounts. And credentials sitting in provider logs are exposed if the provider's infrastructure is breached during the retention window. The first line of defense is your GitGuardian file. Before your first AI-assisted session on any project, make sure these entries are present. .env, .env.local, .m.star.production for environment files. Then add MCP configuration files, Claude desktop config.json, .mcp.json, and mcp-config.json. After adding these entries, verify the exclusion by running git checkignore with the v flag on .env. If there's no output, the file is not excluded, and you need to fix your gitignore before proceeding. Here's a critical point. Gitignore prevents files from being committed to version control, but it does not prevent the AI agent from loading them into its context window. These are two separate protections, and you need both. Most AI coding tools have their own mechanism for excluding files from the agent's context. Cursor uses a cursor ignore file, Claude Code uses its settings.json, Codex uses its config.toml, and Copilot uses a copilot ignore file. Add entries for .env files, .pem and .key files, and MCP configuration files, and never grant AI agents direct access to credential stores or secrets managers. The correct pattern is agents generate code referencing os.environ, and actual values are injected at runtime by your deployment infrastructure. Even with gitignore configured correctly, you should run a secret scanner on your stage changes before every push. This catches anything that may have slipped through. The recommended tool is TruffleHog. Run it with the Git file protocol, since commit head, and the only verified flag. Alternatively, you can use git secrets with the scan command or git leaks with the detect command. If you find a credential that has already been pushed, rotate it immediately. That's your first priority. Then clean up the history using git filter repo. A rotated credential still in history is far less dangerous than an active credential that remains there. Here are the 6 mitigations that work. First, add .env and MCP config files to both your gitignore and your agent's ignore list before any AI session. Second, scan staged changes before every commit using git secrets or TruffleHog. Third, explicitly instruct the AI to use environment variable references, not literal values. Fourth, never paste API keys, connection strings, or passwords into an AI prompt. Fifth, never grant AI agents direct access to credential stores or secrets managers. And sixth, if a credential is accidentally committed, rotate it immediately then remove it from Git history with Git filter repo. To keep secrets out of context windows, configure your git ignore, plus agent ignore lists, plus pre-commit scanning. These three layers together prevent credentials from leaking into your code or into provider logs. In the next section, we'll cover prompt injection in the IDE.